All right, now we're looking at number 9 for the study guide. Number 9 is you're given 4 points, which are the vertices of a quadrilateral, and it says what is the most specific name for quadrilateral ABCD. The easiest way to tell is if you were to graph it and look at it. If not, if you weren't graphing it, you'd have to line up the points and maybe compare the slopes and the distances between the points. But if you can graph it, we can see here that I've got a trapezoid here, and then if I were to compare the slopes of this side of the trapezoid and this side, I would see that they're the same. I'm going over 1 and down 1, 2, 3, 4, 5, 6, 7, over 1, down to 1, 2, 3, 4, 5, 6, 7. So they have the same slope. The points are the same distance from each other. So that means that these two sides of the trapezoid are congruent. Okay, so we have an isosceles trapezoid. Number 10, we've got a rhombus, and the length of AE is x plus 5, and the length of EC is 2x minus 3. Those are parts of the diagonals of a rhombus. And we know with the diagonals of a rhombus, a couple of things is that they bisect each other, and they're also perpendicular to each other. We also learned that they bisect, the diagonals bisect the opposite angles. Okay, so this diagonal bisects angle D and B, and this diagonal A and C. But the question is, which statement best explains why the equation x plus 5 equals 2x minus 3? And that is because the diagonals of a rhombus bisect each other. They cut each other in half. So this length is equal to this length, or x plus 5 is equal to 2x minus 3. All right, let's move on to number 11. We're told that these two triangles are similar. Remember, this is the symbol for similarity. And we learned with similar triangles that the ratios of corresponding sides are congruent. Remember how there's different ways we can identify congruent or corresponding sides or corresponding angles. Remember when we write similarity and congruent statements, the corresponding vertices go in the same order. Okay, in the same spot. So angle A corresponds to angle D, angle B with E, and we could tell that by our similarity statement. Same thing, segment AB corresponds with segment DE, segment BC corresponds with EF, and AC with DF, and so forth. So again, with similar triangles, the ratio of corresponding sides are equal, so we can set up a proportion to solve for these unknowns. Let's use this ratio of corresponding sides, 8 to 5. Okay, so the ratio of those two sides has to equal the ratio of another pair of corresponding sides. Let's solve for x first, and its corresponding side is AC, which is 14 units long. So the ratio of 14 to x has to equal 8 over 5. And remember, when you're building your ratios, go in the same order. I'm going, from the larger triangle to the smaller one for my ratio 8 to 5, so I can't go from the smaller to the larger for my other ratio. I've got to go in the same order. If I go 8, 5, I've got to do 14 over x. If I do 5 over 8, I've got to do x over 14. Okay, then we simply solve a proportion by cross-multiplying the diagonal that has a number in both spots and divide by the other. Okay, that's the short of it. If you were to cross-multiply, you'd have 8x is equal to 70, and then you solve for x. So we multiply 14 times 5, and we divide by 8, and we get x is equal to 8.75. Okay, so we can eliminate a and d. So let's solve for y. And again, I'm just going to use this ratio 8 over 5. I could use, that's the only one I could use. Okay, so 8 over 5 has to equal y, and its corresponding side is 7, y over 7. So we got 8 times 7 is 56, and 56 divided by 5 is 11.2. So y is equal to 11.2. So that leaves us with answer choice, what? B. Alrighty.